Good morning, boys and girls. Today's lesson is on mathematical astronomy. To understand astronomy and mathematics, you must know some mathematical basics. Basics like big numbers. Such big numbers include 1,000 to a decillion. Yes, that'd be 1,000 with one set of zeros to a decillion with 11 sets of zeros. But luckily, all you need to know is 1,000 to a trillion. That's for the basic astronomer. Then, to get through this a little bit easier, we start off with learning prefixes. There is a crapload of them. But we only need to know about 7, luckily. Those 7 prefixes include giga, mega, kilo, centi, milli, micro, and nano. Giga is abbreviated with a capital G, and it equals a billion, which is also 10 to the 9th power. Next is mega, which is abbreviated with a capital M, equals a million, which is 10 to the 6th power. Kilo is abbreviated with either a capital or a lowercase k, which it equals 1,000, which is also equal to 10 to the 3rd power. Centi is a lowercase c, which is equal to 100th, which is 10 to the -2. Milli is a lowercase m, which is 1,000th, and is equal to 10 to the -3rd. Micro is a funny looking u to the cubed power, which equals a millionth, which is also 10 to the -6th power. And last and least is nano, which is a lowercase n, which is a billionth, and also 10 to the -9th power. Scientific notation. By using scientific notation, you can take huge numbers and squeeze them into a more compacted version. Like, for example, you have 9,100,000,000. You can change that into 9.1 times 10 to the 9th power. Greek letters. The Greek letters are alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, psi, omicron, pi, rho, sigma, tau, epsilon, phi, chi, psi, and omega. The only ones that we really need to be worried about are alpha, beta, gamma, delta, epsilon, theta, pi, and sigma. The letters alpha, beta, and gamma are all used in scientific equations. Alpha equals 1, beta equals 2, and gamma equals 3. Delta, which equals 4, is used whenever there is a change in a variable within an equation. Epsilon is the 5th letter in the Greek alphabet, which means it gets a value of 5. In astronomy, it is used to show the 5th brightest star in a constellation. Theta is used in replace of unknown degrees of an angle, and its numerical value is 9. The numerical value 80 is represented by the Greek letter pi. Sigma has a numerical value of 200 and is also used in such concepts as a summation. Okay, so I'm sure I lost most of y'all by now, or at least some of y'all, so it's time for a quick little stretch break. Okay, everyone up on their feet, even you, Mr. Taylor. Let's go. Stretch time, and back down. Proportions. Proportions play a role in the third law of planetary motion, which states that time of one revolution squared is proportional to the semi-major axis cubed, as you can see in the example below. The semi-major axis, which is 100 astronomical units right now, is plugged into where A is, which is the semi-major axis, and X is the variable you solve for. And after all that, you come out to have 1,000 years. Trigonometry. Trigonometry is used in such concepts as finding distances to stars or other objects in space from Earth. This uses a triangle where one point is the star, the other 2 points come from the parallax. Now, the parallax, the easiest way to understand that is for you to hold your thumb out in front of your face, close one eye and look at your thumb, then close the other eye and open the eye that was closed, look at your thumb. And that is the parallax, the two different viewpoints of the thumb. The angle is based on the star's movement against the background. The base of the triangle is the diameter of Earth. Height of the triangle equals distance. And now to tie calculus in with astronomy. Calculus is used in many different ways, and a few ways are such as follows: determining planetary positions, calculating supply needs, to determine how stars are born, live, and die. It helps determine the moon's effect on the tides, any object's gravitational force, any kind of change whatsoever, and classical mechanics, which is like the position and velocity and acceleration functions. Here are the websites I used, and I would like to thank everyone for trying to stay awake through this presentation. Thank you and goodbye.